The term drone means a continuous low humming sound. Now, this might not be the best way to represent these unmanned aerial vehicles, but still it's the most commonly used term. Drones have gained a lot of popularity over the past few years as the technology has advanced and the motors have become cheaper. This has allowed the drones to be used in much more commercial sectors such as photography, filmmaking, surveillance, and even delivery systems. Despite this, drones have a long way ahead. So learning how to program a drone to perform different tasks is becoming an increasingly popular skill. Drones come in different shapes and sizes. A popular term you might have heard for a drone is quadcopter. This refers to a drone with 4 propellers or motors. Similarly, a hexacopter has 6 propellers and an octocopter has 8 propellers. So let's have a look at the main components of a drone. A drone will consist of frame, motors, propellers, electric motor controller, power distribution board, a flight controller, battery, receiver or Bluetooth, a camera, video transmitter, and some sensors. The frame or the body is what holds everything together. Most good drones use carbon fiber as the frame material since it is quite lightweight and strong. Nowadays, a lot of DIY drones use wood and 3D printed frames as well. Motors can be considered as the engine of the system that creates the lift and allows the drone to fly. There are 2 main types of motors used in a drone: brushed and brushless. Brushed motors are simple and cheap, whereas brushless motors are expensive but have a better weight to power ratio. Propellers are what generate the lift force when the motors start rotating. There will be 2 types of propellers for any given drone. One that rotates clockwise and the other that rotates counterclockwise. This is because if all the propellers are rotating in the same direction, the drone will start rotating as well. But since we have half of them rotating in one direction and the other half rotating in the other direction, they can cancel each other out and the drone does not rotate. Propellers can have multiple pairs of blades. The more blades you have, the more thrust it will generate, but the more inefficient they get. The electric motor controller or the ESC is what controls the speed of the motors. They convert the DC signal from the battery to AC signal for the motor. You can have separate ESC for each motor or a single board with multiple ESCs on it. Power distribution boards allow battery to power all the components, including the motors and the flight controller. The flight controller is the brain of the system and it decides what should be the speed of the motors based on the input received from the sensors and the receiver. The battery will power all the components of the drone. This has to be light and efficient at the same time to allow maximum flight time. The receiver or the Bluetooth allows transmission of the signals between the remote and the drone. Most of the times we will also have a camera attached to the drone along with either an SD card storage or antennas for wireless video transmission. Now, to transmit video, we need video transmitter. This device is responsible for the transmission of video through the antenna to your cell phone or the FPV remote. There are multiple sensors attached to a drone. For example, the pressure sensor measures the altitude or the distance between the ground and the drone. The GPS locates the position of the drone, whereas an IMU measures the acceleration and the angles at which the drone is. The movement of a drone seems quite complicated as it has 4 or more motors to enable all movements. But in reality, it's quite simple and intuitive. The drone can move with 4 degrees of freedom, which means it can translate in 3 directions and rotate in 1. As mentioned earlier, 2 propellers of a quadcopter rotate in clockwise direction and the other 2 rotate in the counterclockwise direction. This generates a zero angular momentum that allows the drone to stay stationary rather than rotating in one direction. Let's have a look at the translation movements first. First, we will run all the motors at the same speed that will generate the lift greater than the weight of the drone. This will cause the drone to move up. This is the first translational movement. If we want to go down, we will decrease the speed of all motors so that the lift is less than the weight of the drone. If we want to hover in the air, we will change the speed of the motors so that the lift is equal to the weight of the drone. This will allow the drone to hover above the ground. Now coming to the second translation, if we want to move left, we will reduce the speed of the left motors and increase the speed of the right motors. To move towards the right, we will decrease the speed of the right motors and increase the speed of the left motors. Similarly, we can translate in the third direction, which is moving forwards and backwards. By decreasing the speed of the front motors and increasing the speed of the back motors, the drone will move forward. For moving backwards, we can decrease the speed of the back motors and increase the speed of the front motors. Since 2 motors are rotating in clockwise and the other 2 are rotating in counterclockwise direction, we can use this knowledge to rotate our drone. To rotate the drone clockwise, we will decrease the speed of the motors moving clockwise and increase the speed of the motors moving counterclockwise. Similarly, if we want to rotate counterclockwise, we will decrease the speed of the counterclockwise motors and increase the speed of the clockwise motors. Now that we understand how the drone flies, let's have a look at the drone we will be using for this course. The drone that we will be using for this course is the Tello drone. Now, this drone is recommended to be used with this course, but that does not mean that you cannot apply the same techniques to other drones. In fact, 80% of this course is applicable to any drone and only 20% is specific to the Tello drone. The Tello drone is produced by the company Rise and it contains DJI and Intel technologies for flight control. It is a compact drone with a camera attached to it that can shoot up to 720p video at 30 frames per second. It is quite easy and safe to use indoors because it has multiple safety features. Now, this video is not sponsored by any of the companies including Rise, DJI or Intel, and this is my honest opinion that Tello is one of the best drones to get started with if you want to learn programming of drones. The best part about this drone is that it is programmable, which means using an SDK we can control the movement of the drone and apply computer vision techniques without any external wiring. That's right, everything will be done over the Wi-Fi and you do not need even a router for it. In fact, they have added 2 antennas which will allow stable video transmission. The total flight time for this drone is about 13 minutes and the flight distance is about 100 meters with the top speed at 8 meters per second. When getting the drone, you have multiple options. The first one is regular pack and the second one is jumbo pack. There are also 2 types of Tello drones. One is regular and the other one is EDU, which is the educational. This course is compatible with both types of drones. If you get the regular pack, it will come with a single battery, extra propellers and the propeller guards. The charging would be done connecting a USB cable directly to the drone. On the other hand, if you get the Tello Jumbo pack, then you will get everything as before, plus 2 extra batteries and a 3-slot battery charging hub. The Jumbo Pack is much better for programming because with 3 batteries you can do a lot more testing, and while you are using one battery you can charge the other one so that you do not have any delays.